So the project that we have done is pest recognition and classification using CNN and Transformer. So myself, I'm Joshika from Epcoshlank Engineering College of CSE department.
I'm Janani from final year CSE department.
I'm Kritika from final year CSE department.
Beginning with the introduction, pests cause big problems in farming by reducing crop productivity and causing money loss. In traditional methods, finding pests are slow, costly, and often don't work well. A small solution is to use deep learning, especially a mix of CNN and transformer, to identify pests more accurately and quickly. Problem statement. The goal is to create a deep learning system that can detect pests in images and classify them into specific types. This helps in managing pests better, which boosts crop yield and efficiency in agriculture. Objectives. Detect pests in form images using deep learning. Classify pests correctly into their types using a model that combines CNN and transformer technology.
This project, our goal was to develop an effective pest recognition system using a hybrid deep learning model that integrates convolution neural network and transformer. The system follows a structured pipeline that includes the following stages. First, data preprocessing. We start with DNA dataset, which include 4,500 images across 40 pest classes. Images are resized, flipped, randomly rotated, and normalized to improve the model's robustness. Next, feature extraction. This performed using two models in parallel method. One is CNN, which include ResNet 50 architecture, and the transformer, which is a vision transformer. Next stage is feature fusion. The output from CNN and transformer fused to form rich representation of pest features. The last model is classification. A fully connected layer with softmax activation classifies the pests into their respective classes.
So let's look at the tangible outcomes of the project. So it currently fits the pest class name, like for the pest over here, it says as Ocanthus pelusens. And let's move on to the next performance metrics. The first one is confusion metrics. It is actually like the comparison between the uh, correct labels and those predicted labels. And if you see in this, the diagonal values are quite high. It says that all these were predicted correct. Accuracy is nothing but the ratio of total positive values by total values. The next comes to decision, which is nothing but the predicted positive samples that were actually identified correct. Recall is nothing but the basic the how many positive samples were identified. And F1 score is nothing but it is the balance between the previous precision and recall that we saw. All these were the evaluation metrics. And now coming on to this curve, both these actually decrease over time. So it says the model has generalized well. And this one, at the first, it has seen a great height and then it goes out well. So no more fluctuations. This is the computation cost and it serves very well, like 6 times efficient. So the social impacts of this project are if the pesticides identified very much earlier, then the pesticides use can be very reduced. So if this is come into action, then both the technology and farming actually goes hand in hand. That's it.